Hello and welcome to Machine Learning First Steps. Today we're going to introduce the utilities or software programs that we need to install on our laptops or PCs in order to start working in our machine learning project. So we need guns, lots of guns. So which utilities do we need for our tutorials? Basically we need a PC with Ubuntu 20.04 installed, and this is a basic requirement. Also, we're going to work on installing Anaconda, which is a virtual environment program that allows us to create virtual environments for our projects with Python 3.9 installed. So Python is going to be the basic programming language that we're going to rely on in our machine learning projects. If you're not familiar with Python, don't worry, we're going to talk about that during the tutorials. Also, we're going to talk about the installation of the Anaconda virtual environment program. Also, we're going to install Tensorflow together, and despite the fact that we're not going to talk about Tensorflow right now, but we still need to install it for future projects. Also, we need to install Spider IDE. IDE stands for Integrated Development Environment, and we're going to talk about that in the next slide. So basically what I first need to talk about is a virtual environment. What is a virtual environment? If you watch the movie The Matrix, you'll find that there was a concept of something called a construct, which is a virtual environment or a virtual simulation apart from the Matrix itself, in which Morpheus trained Neo. The same thing could be applied here, and if you didn't watch the movie, we'll just explain the concept right away. Basically, you have your system environment in which you install basic packages that you need to work on your projects. But the thing is, some packages have conflicting dependencies or might be conflicting in their nature. For example, if you happen to be someone who works on machine learning projects and at the same time tends to work on some web development projects, then you're gonna need to use Python 3 for your machine learning projects, and also you're going to use Python 2 for your web development projects. And the thing is, you can't just work on both at the same time. The system needs to have one default Python language source, maybe. We can call it that. So in order to escape that, in order to have multiple packages installed on the same device, we create virtual environments. And by virtual environments, I mean that we have different environments other than the system environment itself in which the same user can install different packages. So each environment can run a different set of projects. And this makes the whole project creation and development process very flexible, since you will need to specify the environment that you need to work on currently. And you can shift between environments, which makes you quite flexible and makes the development process much easier. So now we're going to create a virtual environment for our machine learning projects, and we're going to use Python 3.9 for that. So the second question is, what is an integrated development environment or an IDE? Basically, in the old times, people used to write their code in text files using Notepad or some other softwares. But today, thank God, we have integrated development environments which could help us work on our code in a much simpler way, because they provide a lot of functionalities, like having a cool GUI that makes you look like a really cool hacker, and at the same time, it colors your most important keywords. So you'll find that different words in your code have different colors in order to show their type, maybe which type of keyword you're using right now, as well as displaying errors right on the spot instead of just having a pure text file that shows nothing but the code itself, and then when you try to run it, you'll find that there might be errors that you didn't notice or observe at the beginning of your code writing process, for example. Also, it provides some cool extra features like auto-completion, where you don't have to memorize every single command. It just provides auto-completion for you in case you forgot the whole command. Also, it has many cool debugging utilities, which allows you to debug your project before running it, and searching for errors and troubleshooting and stuff like that. So basically, IDEs make our lives easier, and we have to rely on IDEs or code editors maybe, if we want to work on our projects in a very smooth manner. So these are some important links that we're going to use in our installation parts of the tutorial right now. So you got Anaconda and Tensorflow. Also we got Spider, but that seems to be like some part of Anaconda installation, so it is embedded within the same link actually. So let's go and let's dive in and let us install our prerequisite software tools. So here we have an Ubuntu 20.04 installed on my laptop, and it just looks like this once you log in and once you start or boot your system. So there are so many ways to install Ubuntu, and it is an open source operating system, which makes it free, and it has a lot of user support, which makes it very suitable for robotics applications, since you don't pay for any license or any installation utilities. So once you have Ubuntu installed, we can just learn about some cool utilities, like for example the terminal. So I'm going to press Ctrl-Alt-T in order to open up a new terminal. You will find a word here in my own terminal called base, which you're probably not going to find in your own bash terminal. You don't have to worry about that. We'll just know how this came to exist later in this video. So right now, once you open up the terminal, you will find that your terminal is set at your home directory. And that means that this is equivalent to the GUI here being set in this particular location, which is your home directory. So there are a couple of commands that would help you do things the old-fashioned way, like for example listing the folders that are there in the home directory using a command called ls, which is short for list. So what this does is basically it shows the folders and files that are available in your home directory. You can find these in your home directory using the GUI, or you can use the terminal. The thing is, the terminal is very useful when it comes to machine learning applications and many other applications that require actually the usage of a Linux-based system. So the old-fashioned way is not always bad. Also, you can use some functionalities, like for example navigating to another directory. So let's just say here I'm in my home directory and I need to go, for example, to the music directory. So when you do it in the GUI, you basically click in the window that you want to show up and you just navigate. It's quite easy. If you want to do that the old-fashioned way, you can use a command called change directory, or CD, and you kind of type music. So what this does basically is it just changes or sets the current directory of your bash terminal to the music directory instead of the home directory. And if you want to get back to your parent directory, which is the home directory in this case, you can just type cd and then just 2 dots, and that's it. You're back in the home directory. And you can also for example, here in the GUI, you can create a new folder, for example, and you can name it, for example, Sam. You can do the same thing using the terminal. So basically, I'm going to change my directory back to music, and I want to create a new folder. So I'm going to use a command called make directory, which is mkdir, and I'm going to call it sam2, for example. So what this does is that it adds another directory or another folder to my music directory called sam2. Also, you can create a new text file, for example, using a command called touch, and I'm going to type touch, for example, sam3.text, and I'm adding the text extension just to declare that this is a text file. And when I open it up, we have a sam3 text file. So when it comes to these basic functionalities, you can either use the GUI or the terminal. The terminal is not the easier choice in this case, but you will find that the terminal is much more useful in other applications, like for example the installation and downloads, downloading of several packages, for example. So you can just do that using the terminal right away. You can also execute or run your codes and make directories or make your codes. It's just an operation called make, like building your project, for example. So it's quite similar to that. You can use the terminal for that as well, and you can use the terminal for running specific programs right away without looking them up in your GUI. So the terminal is quite useful for a lot of applications, and this is why we're going to rely on the terminal a lot during this course. Alright, for the first part of our tutorial, we will install Anaconda. So how are we going to do that? First, I'm going to go to my Firefox browser in Ubuntu, and then I'm going to type anaconda.com. Sorry. And I'm going to navigate. Oh, actually it showed up right away. That's good. So first of all, you'll download this folder or this file here. So here it explicitly specifies that this version is for Linux, which happens to be our operating system. And we got Python 3.9, and this is the 64-bit device. So yeah, we're good to go. So I'll just download this file. Click download. Yeah. So it'll take around minutes here to show up. Alright, so the installation is complete. You can find the file here in your downloads. So what I'm going to do is I'm going to open up a terminal using Control-Alt-T. So here you'll find that the only difference between your terminal and mine is this word base. Just ignore it for now. Alright, so what you're going to do now is you're going to type bash, and then you're going to head to the directory where you saved the file. So this directory is home, and then you got downloads. And what you're going to do next is you're going to copy the folder name. So this new folder, I guess, was, well, let's just open up the documents and let's just, yeah, here it is. So what I'm going to do is I'm going to type or click rename and copy the file name. And then I'm going to paste it here. But I'm not going to press enter because I have Anaconda already installed on my laptop. So I'm not going to press enter, but you are going to press enter. So once you do that, Anaconda will start installing, and then it will keep asking you for either your password or your approval for some license issues. So what you're going to do is that when you're prompted to provide your password, you're just going to provide it and hit enter. Or when you're going to approve something, it's going to ask you to type yes. So you're going to type basically yes and then hit enter. And once the installation is complete, you now have Anaconda installed on your PC or in your operating system. So you can close your terminal and you can open up a new one. So Control-Alt-T again. You're supposed to find this base word. And if you don't find it, you can just, or if you happen to run one of the Anaconda commands and then there is a problem showing up or an error showing up, dictating that you don't have Anaconda installed, you're just going to type bash, you're going to type source and bash rc. So what is the bash rc? Basically, what you're trying to do here is to include Anaconda as part of your startup or as part of the startup operation of your bash terminal. And what the bash terminal is this like violet or purple interface here. So if you go back to your home and you press Control H, you'll find that there is a hidden folder right here, or a hidden file here, called bashrc. So if you open it up, you're supposed to find some statements at the end of the file related to the initialization of Conda. So once you have that, you're good to go. Right? So I'm going to get back to my terminal. So now once I had Anaconda installed, I now have the ability to create virtual environments. So what I'm going to do is I'm going to open up this cheat sheet here provided by Anaconda support. So this cheat sheet contains all the commands related to Anaconda. For example, here for the Conda basics, you have some commands that have to do with the information. For example, verify Conda is installed and check version number. So I'm going to type this command here just for illustration, and I'm going to type Conda info, for example. So it's going to display the information of your current Anaconda version. And there are also some commands relating to updating Anaconda or updating Conda. And yeah, you're basically going to find a lot of useful commands here. So what I'm going to do now is I need to create a new environment with any name. All right. So here, this is an example which shows the creation of an environment called Pi35. So let's just say that you need to create a virtual environment for your projects for this course. So what I'm going to do now is I'm going to type this particular command, which is conda create name, and I'm going to call my environment invsam, for example. And then Python, I need to declare the Python version I want for this particular environment. And since we're going to be working on Python 3.9, I'm just going to pick that. So I'm going to press enter. And then yes. Alright, congrats. Now we have a virtual environment created that is called invsam. But the thing is, I'm still located in the base environment, and this is, well, it's just the base, alright? So I need to navigate to my special environment, which is invsam, so I need to activate it, because currently the active environment is the base environment, and I want to activate my invsam environment instead. So what I'm going to do here is I'm going to type conda activate invsam. And congratulations, you can find that the environment name has changed from base to invsam. And now I'm in my environment, or the environment that I picked for this course. So what I'm going to do next is I want to install Spider, which is the IDE I talked about. And it happens to be among the many things that you can install using Anaconda. So I want to install Spider for this particular invsam environment. So let us check for the appropriate command for that. I need to install a new package. So for example, here you can find the command for installing a new package. Here the user is installing Jupyter, for example, but I need to install Spider. So what I'm going to type is conda install, Spider. And I'm going to hit enter. So now it's installing Spider for me. I'm going to type yes or Y and then hit enter. All right, great. Now we're done. Now we can use Spider. So in order to open Spider, what I'm going to do is type Spider and hit enter. All right, now we have Spider installed. So in your case, of course, it's going to be empty because you don't have any projects yet, and that's it. And once I need to close Spider, I can either do that from the GUI here, or I'm just gonna type Control-C here to kill this process. And that's it for Conda installation. Alright, for this part of the tutorial, we'll talk about the installation of Tensorflow, which is a platform for machine learning. So what we want to do is to head to the Tensorflow installation official page here. And before we proceed with the installation, we need to talk about something called a GPU. So what a GPU is, it's a processing unit that enables your computer to perform parallel computing, which is a feature that will make machine learning much easier and much faster. So the process of training your neural network, for example, will take much lesser time because of this feature. And because not all machines or not all devices have GPUs installed on them, so you gotta check first if your machine or your PC or your laptop has GPUs installed. If they are not installed, don't worry, you don't need them, not necessarily. They're just gonna make the process much faster for you. And if you don't have them, you can still install TensorFlow all the same. So let's get started. So basically here, the page will display the hardware requirements. And by the way, this page link has been added here. The third link, which is the TensorFlow link. So you can just check the slides if you can't find the link. So first of all, here the page is talking about the GPU-enabled devices. If your device happens to support GPU applications, these are the NVIDIA cards that are the acceptable NVIDIA cards or acceptable hardware. In case you don't have them, as I said before, it's okay. Okay. So basically, if you do have a GPU card, you gotta check its version, for example, or its name. But it's alright, you can recheck that at a later stage if you happen to have a GPU device installed. So you just have to skim through this part, nothing more. So basically here the system requirements are pretty important. So you have to have Ubuntu 16.04 or higher, and since I have 20.04, then I'm good to go. And the rest are just like other operating systems, but we're basically operating on Ubuntu right now, so I don't have to worry about that part either. And you have some software requirements. So you gotta have a version of Python that's between 3.7 and 3.10. We already installed Python 3.9 using Anaconda, so we don't have to worry about that. And you gotta have a pip install or a pip package installed. And if you don't have it, don't worry, you can just install it. You can search online for how to install a pip package, for example, in Ubuntu, for example. So yeah, you'll find a lot of resources for how to install pip or pipe. Some people call it pipe, some people call it pip. I'm not really sure. But it's an abbreviation anyway, so you can just pronounce it the way you want. So yeah, we'll find a couple of steps here where you can actually install pip if you don't have it. Yeah. So yeah, you basically are gonna run these commands. You don't have to do anything else other than that, just these commands. All right. So with that said, we can skip that now, or can skip that requirement since we already know how to get it. Okay, you don't have we don't have Windows, so you don't have to worry about that. And yeah, in case you have a GPU installed on your device, you need to install a driver for that GPU. And what a driver is, it's basically a piece of software that is used to manage the GPU hardware itself. And Anyway, all of these requirements, we're gonna walk through these requirements later in the page. So we'll just keep that on the side for now. Now we have the step-by-step instructions. These are basically the system requirements all over again. So we already checked that. Here you'll find a step called install Miniconda, and Miniconda is like a mini version of our Anaconda. So since you've already installed Anaconda, you don't need to reinstall Miniconda, and you don't need to install Anaconda because you already did that. So you're just gonna skip step number 2 here. You will find that step number 3 dictates that you need to create a Conda environment, which we already did. This is the basic command that we ran before. So basically here he created a new environment called Tensorflow, which is a special environment for TensorFlow applications, just like the InfSam environment that I've just created. So you can call it whatever, it doesn't matter. And you need to activate that environment as we did before. So this requirement has been done already or secured. So then we have the GPU setup, and you can skip this section if you don't have a GPU, if you just run your TensorFlow applications on a normal CPU. So in case you do have a GPU setup, you can open up a terminal. So I'm just Control-Alt-T, and you can navigate to your or activate your special environment. So I'm just gonna say Conda activate InfSam. So now I'm in my special environment. You can run this set of commands to check if you have a GPU driver installed. In case you don't have, you will first need to install an NVIDIA GPU software driver. So you're gonna click this link, and here you got the NVIDIA driver downloads that are offered by the NVIDIA website. So basically here I got a GeForce product type, and my series, the series of my own device, is RTX 20 series because I got a GPU installed on my laptop. And my specific product name is RTX 2060, and this is my operating system, Linux 64-bit. And the rest are just like the language and stuff like that. So I need to search for the latest driver that's been produced for my own GPU setup. So this is the version I'm gonna need, which is 5.15 basically, 5.15.76. You're just gonna type 5.15. But how am I gonna install that? All right, now I know the version. How am I gonna install that? So once you happen to know the version, you can just open up the slides and you'll find a link that explains how to install the NVIDIA driver. And the only variable parameter in this installation process is the number of your version. So you're going to supply that in order to fit with your own GPU setup. This is the only parameter that you have to change. But you have to follow the rest of the steps just as is. You don't have to change anything. And if you do have a GPU driver installed on your PC, you don't have to worry about that at all, as you don't have to install a GPU driver. But most likely, if your operating system is brand new or installed lately, you will most likely need a GPU driver in case you have a GPU setup. So now, after you've installed the NVIDIA GPU driver, you need to check if it was properly installed. So you'll basically run this command in your terminal. So what you're going to do is you copy the command, you go to the terminal, you just type NVIDIA SMI, and you just hit enter. And because I have a GPU driver installed, so it basically dictated what my version is, which is 5.15.76, as we checked on the website. In case that doesn't show up, then that means there was something wrong with your GPU driver installation, and you just need to remove that version that you've installed maybe there was something wrong with the installation, and reinstall it properly. But that most likely won't happen if you follow the exact same steps that were provided in the video link that I provided in the slides. So once you're done with the GPU driver setup, you need to install CUDA and CUDNN with Conda. So these are like package managers or kernel managers. You don't need to worry about what they actually are. They're just like supporting pieces of software that are needed for your machine learning applications. So what you're going to do is you're going to install these pieces of software using conda install. So you're just going to type this command into your terminal and just install them. But within, as I said before, within your special environment for machine learning applications. So what you need to do next is some extra steps like configure system paths, and you're just gonna copy commands and place them in your terminal and just hit enter. So you needn't worry about these steps. Finally, once you're done with the software and hardware requirements, you're gonna get to the install TensorFlow part. And basically what you're gonna do, you're gonna use the pip package that you installed earlier in order to install TensorFlow itself. So you're gonna copy that, you're gonna copy this command, and you're just gonna place it in your terminal and within your special environment again, because this is a main requirement. You can't install these on the base, and you actually can install these on the base, but we don't want to do that. We want to install them within our special environment. So you're going to, after you've upgraded your pip package, this is basically like checking whether your pip package is upgraded or not, or you have the latest version or not. And then after you're done with this step, you'll basically install TensorFlow using pip or pipe on your terminal. And then once you're done with that, you need to verify your installation. So basically here you have two options. If you have a CPU setup, like you don't have a GPU device, and you happen to have a normal device with no GPU attached, you can just like run this command and copy it and just verify the installation. And if a tensor is returned, so basically a tensor is a type of variable that we're going to talk about once we get to the TensorFlow part. So you'll find like something has been returned that looks like, I don't know, an OK message basically. And if you have a GPU setup, then you're going to have another message by typing this command in your terminal and just hitting enter. Then a list of GPU devices will be returned. And as far as I remember, it was something like GPU device equals 0 or something like that. As long as you get some kind of message that talks about your GPU device, then you're good to go, right? So yeah, basically these are the things that you need. Yeah, so this is the TensorFlow installation, and it shouldn't take very long. I mean, there are some parts of the installations that take long, like the installation of CUDA, for example. That's going to take a while, but everything should run just fine. And luckily, you have like some commands to verify each step of the installation process. So you should run these, and if everything goes okay, then you're good to go, and we have TensorFlow installed. So let us summarize what we've done so far. So basically, we needed some extra software support, like virtual environment software, other software utilities that we need to create our machine learning projects. We were briefly introduced to Ubuntu as an operating system and how it works. We also now know what a virtual environment is and how to install Anaconda. Also, how to create virtual environments for our different projects, including our machine learning projects. We also installed an IDE called Spider, and we learned what an IDE is and what it does. We also installed TensorFlow, which we're gonna use for machine learning applications later in the course.